Okay, so today we will continue the lectures in section 3.5, complex zeros are polynomials. So in the previous class, so we talked about what is a complex number, right? Today I will show you how to solve quadratic equations. We know how to solve the quadratic equation by using the formula, right? But in the case discriminant is less than 0, in this case, we don't have the real solution. But we have the complex solutions. So the question is, how do we find the complex solutions? Okay, so I start here. We consider the equation ax squared plus bx plus c equals 0, and a here is not 0. Okay. So the discriminant is b squared minus 4 times a times c, right? You already know how to solve, right? This equation in the case where d is greater than 0 or d equals 0, right? So you know how to do that. But in the case d is less than 0, we don't have real solution. In the case d less than 0, we don't have real solution, right? Real solution. But we have the complex solution. Complex solutions. So how do we find the complex solutions in this case? Okay, I will provide you the formula to find the complex solutions in this case. Okay, but in the case d less than 0, we have two complex solutions. Okay, when d less than 0, we have two complex solutions. Two complex solutions is as follow. The first solution is given by this formula, negative b plus I times the square root of absolute value of d over 2a. And the second solution is negative b minus I times square root of absolute value of d divided by 2a. Okay, so that is the formula for the complex solutions. Okay, and I will show you some example to illustrate this formula. Okay, example 1. Okay, solve the equations. X squared plus x plus 1 equals 0. Okay. Okay, so now we need to determine the coefficients of this equation. So could you tell me the coefficients A, B, C in these equations? Who can help me to do? Well, could you tell me the coefficient A, B, and C here?
All of them would be 1.
Sorry, can we, right? Who answered this?
All of them would be 1.
Okay, A equal 1, B equal 1, C equal 1. Yeah, exactly. Thank you, Mohammed. 1. Okay, exactly. So now we need to calculate the discriminant d. D equal to b squared minus 4ac. So could you tell me how much? How much? Anybody? Tell me.
What is 3?
Sorry, it's -3.
It's -3.
Yeah, exactly. Yeah, thank you. It's -3. Yeah, exactly. In this case, we see that -3 less than 0, right? In the previous class, if d is negative, is d is less than 0, so we can look that there is no solution, no real solution. But in this case, we have two complex solution. Okay, the complex is different from the real. Okay, here we have, so we imply that we have two complex solution. Like solutions. Okay, the first one is -b minus I times square root of absolute value of d over 2a. Okay, so now we will relate b and d and a to this formula, right? So we have b here 1, right? -1 minus I times square root of d of absolute value of d. So okay, so what is the absolute value of d? Okay,
Would it be -3?
no, the absolute value.
Oh,
3.
Yeah, absolute value here of -3 is 3, right? Okay, so be careful here. Be careful here. You need to make the absolute value here. Okay, d is -3, but the absolute value of -3 is 3. Okay, so now put to this here. Okay, 2 times a, 2 times 1. Okay, so now we simplify this. It's -1 minus I times square root of 3 over 2. Okay, sometimes we can write like this. Sometimes we can write like this. Okay, so now you see it's the standard form of complex number. Okay, okay, another one, x1 here and x2 here is -b plus I times square root of absolute value of d over 2a. Okay, so now we relate b, d, and 2a and a to this formula. So we have b here is 1, right? So put 1 here, and d, then absolute value d here is 3. Okay, and 2 times 1 is 2. Okay, so do the similar thing, so we can write as like this. Okay, so we have two solutions here. Okay, that is the answer for this equation. That is two solutions for these equations. Any questions so far? Is it clear, guys?
Yeah.
Clear, right? Okay. Okay, so that is the way to solve the quadratic equation in the case the discriminant is less than 0. Okay, I can give you another example. What else to practice? Example 2. Solve the equation. Solve the equations. X squared plus 2x plus 4 is 0. Okay, think about this. Try to do it in 1 minute and let me know the answer. Think about it. Okay, so now I will show you to solve this equation. First of all, we need to determine the coefficients of this equations. A here is 1, B here 2, and C here 4, right? Okay, so the discriminant now is B squared minus 4 times A times C. Now we relate B by 2 squared. B squared is 2 squared minus 4 times A here is 1, C here 4. Okay, so we have 4 minus 16, right? So we have this in negative 12. So is it less than 0? Okay, so this is the case. So we have 2 solutions, right? 2 complex solutions. Okay, not 2 real solutions. Okay, so we have 2 complex solutions. So we need to find the absolute value of D. Here is 12, right? Okay. The formula is as follows. You know about this, right? 2A. So now we will relate B now is 2 minus I times square root of 12, right? Over 2 times 1. So we have this is 2 minus I times square root of 12 over 2. Okay, we need to simplify this. 2 over 2 is 1 and minus I square root of 12 over 2. Okay. And now you can simplify more because the square root of 12, so you can write it 4 times 2, right? No, sorry, 4 times 3. Sorry for this. It's 4 times 3, not 4 times 2. Okay.
Hey, Professor, what was the
Okay.
original equation?
Sorry.
What was the original equation?
Good. Will you ask this setup? This step?
Yeah, what was the equation? What was the equation we have to solve? Can we scroll up?
Yeah. This equation.
2x negative b. So wouldn't it be negative 2? It would be negative 1 minus I root 12 over 2, right?
You ask about the discriminant or you ask about the solutions?
Well, because b equals 2. So negative
Equals.
b. Yeah, so negative b would be negative 2.
Yeah, exactly. Okay. Sorry for this. I forgot
No,
the
it's
sign
okay.
here. Okay. Thank you, Cole. Okay, exactly.
So negative 1 too, right? It's a negative 1.
Yeah. Yeah, negative 1. Exactly, negative 1. Okay. Okay, let me write down here. Okay. Exactly. Thank you. Yeah, very good.
No
So
problem.
B here is 2, so it's in negative 2. Okay, exactly. Okay, so now we need to simplify more. So I times square root of 4 times square root of 3 over 2. So now you see this square root of 4 is 2, right? So I times 2 times square root of 3 over 2. So 2 over 2, so it's the 1. So now you can write the negative 1 minus I times square root of 3. So that is the solutions. Okay. You need to simplify this. And another one here is you can find another one, x1. The second solution is like this, right? Over 2a. So now we will relate b by negative 2. Okay, b by 2. Okay, and plus I times 12 over 2. Okay, and you do the similar step like this, similar. So you could still get the result at negative 1 plus I times square root of 3. Okay, it's similar. So you need to simplify this to this form. Any questions? Okay, hope it's clear for all of you. Okay, so that is the way to solve quadratic equations by in the case where the discriminant is less than 0. We can solve like this. Okay, and so I will give you some other problems related to the complex number, and this appears often in the final exams. So I will give you some examples. Example 3. Okay, so now I will combine a lot of kind of problems like factoring, something like this, divisions, and complex number into this problem. Okay, so let's the polynomial px is given by formula here. X squared minus 9x plus 9. Okay, so they give you, given that x squared plus 9 is a factor of px. Okay, we have two questions. The first one, factor px. Okay, the second one is phi or 0 of this polynomial. Okay, this polynomial. And that is the example 3. So this kind of problems appears a lot in the final exams. I will show you how to do this. We'll show you. And the first thing you know, x squared plus 9 is a factor of px. This means that the information x squared plus 9 is a factor of px, right? So we can imply this. Px can be written as x squared plus 9 times 2 qx, where qx here is a quotient. It's a quotient. When we divide px by this polynomial. Okay, so to find the polynomial qx here, you just divide px by x squared plus 9. Okay, to do this, so you use long division, which is the method we use to divide two polynomials. Okay, so now we need to divide the two polynomials. Okay, we use long division to do this. Okay, here we have this is dividend, and here we have the divisor. Okay, so the first thing when we divide two polynomials, we need to write divisor in the left and the dividend in the right, right? So I put x squared plus 9 here. Okay, because we don't have x, so I write 0 times x plus 9. Okay, in the left. So that is the divisor. And put the dividend in the right. Dividend here is this polynomials, x4 minus x cubed plus 10x squared minus 9x plus 9. Okay. Okay, so now we will divide these two polynomials. Okay. So the first thing first, we need to determine here is we need to determine. Oh, sorry. Oh. Okay, my mistake. Okay, we need to determine the leader term in both polynomials. Okay, this is the leader terms, right? So that's after that we divide the leader term together. x4 divided by x squared, so it's equal to x squared. So you put x squared to this line. Okay. After that, you multiply x squared to the divisor, right? Okay, after that you multiply this guy to the divisor. x squared times this guy. So you will get the result with x4 plus 9x squared. And you need to write this guy to this line. Okay. x4 plus 9x squared. Okay. Okay, and now we need to subtract to these polynomial here. So x4 minus x4 is 0, right? Negative x cubed minus 0, so it's in negative x cubed. 10x squared minus 9x squared is x squared. Right? And negative 9x plus 9, okay. And now we have new polynomials. So you see the new little term now is negative x cubed, right? So divide the little term together. So we have negative x cubed divided by x squared. So it's in negative x, right? So you need to put negative x to this line. Okay. And after that, you multiply negative x to the divisor. Okay, one more time. Similarly, time to the divisor. So you will get this guy is negative x cubed minus 9x. Okay, so put it in the line here. So you will receive the result is negative x cubed minus x cubed is 0. You don't need to put here. So x squared minus 0, x squared. Negative 9x minus of negative 9x is 0. Okay, so we have only negative 9 plus 9 here. Do we stop here or we continue the division? We stop right here or we continue? Hi guys, we continue here or we stop here?
We continue.
Okay, we continue because the degree here is 2, but the degree of divisor is also 2. So we need to continue, not stop here. Okay. So x squared here, the little term now is x squared, so divide by x squared is 1. So put 1 to this line. And after that you multiply again. So we have the remainder now is 0. Okay. So could you tell me what is the quotient in this case? What is the quotient polynomials? What is the quotient here? Could you tell me what is the quotient here?
X squared minus x plus 1.
Exactly. Thank you, Mohammed. Exactly. This is the quotients. This is the quotients we need to find. Okay. And after that, we guess the quotient now is like that. The QX now is x squared minus x plus 1. Okay. That we can factor px like this. So the result here is px here is, okay, px here x squared plus 9 times to the quotient. Right? So the answer is like this. Okay. That is the polynomials that we need to factorize. Okay. Because we cannot factorize x squared minus x plus 1. Okay. So we stop right here. In the case you can factorize the polynomial qx, so you can continue to do this. But in this case, we cannot factorize this. Okay. And that we finish the question A. Okay, we finish the question A, factor the polynomial px. So now we move on to the question B. We need to find all the zeros of px. We need to find all the zero of px. When we talk about the zero here, if they don't mention real or complex, that means you need to find all the complex zeros. Okay, if they don't mention anything about a zero, the type of zero, that means that they ask you to find a complex zero, not real zero. Okay, if they ask you to find the real zero, that means you need to find real zero. But if they don't ask you anything about the type of zero, like 5 or 0. Don't mention about the real or complex. That means they want you to find the complex 0. Real and complex 0. Okay, so now we go to B, the property of this question. So 5 or 0. Or zeros, px. So now we have the px now in question A is like this. Okay. We want to, if you want to find 0, so you need to put px is 0, and you need to solve this equation. Okay. We need to solve these equations. Okay, solve for x. Okay, so we have the product of two polynomials is 0. That means that one of them is 0. Okay, in this case, we have x squared plus 9 is 0, or x squared minus x plus 1 is 0. And now you will solve both quadratic equations. And at the beginning of the class, I have told you the formula for solving the quadratic equation. So now you can apply them to do these examples. Okay, so now I will start with the first equations. X squared plus 9 equals 0. Okay. So here we can determine the coefficient A here is 1, right? B here is, could you tell me what is B now? What is B now? Is 9?
0.
Okay, 0. Okay, not 9, because we don't have the coefficient of x here. That means that the coefficient here is 0. Okay. Thank you, Chelsea. C here is 9. Okay. So the discriminant now is b squared minus 4 times a times c. So 0 squared minus 4 times 1 times 9. Okay. So we get this in negative 36. It's less than 0. Okay. So we have two complex solutions. Okay. In this case, we can imply that the absolute value of d is 36. Okay. So we have two solutions as follow. I times square root d here to a. So replace b by 0. Okay, negative 0 plus I times 36. Okay, 2. Okay. So the answer should be the square root of 36. Could you tell me how much? 36. 9 times 4. Okay.
6.
6, exactly 6. Okay, so now we have I square root of 6. Oh, sorry, not 6. Don't have square root now. So I times 6 over 2. So we have this is 3i. Okay. Similarly, you have this guy. Sorry, it's minus over 2a. So relate by minus, I times square root of 36 over 2. So it will have negative I times 6 over 2. So it's negative 3i. So the solution for the first equation is 3i and negative 3i. Okay. Any questions? Okay,
Yeah,
Chelsea.
I have a
Okay.
question. So like specifically for this one, since it works with the x squared plus 9 equals 0, do we have to go through all that? Because you can just, like subtract the 9 over from each side and then take the square root of negative 9 and then multiply out the square root of 9 and then the I, so then it would be plus or minus 3i.
Yeah,
Or do we have to
exactly.
go through that full thing?
Yeah, I know. Yeah, thank you, Chelsea. So, yeah, you can do it. Here,
Okay.
I just want to give you to apply the formula But you can do like this. This is faster than this one, but here is just the way you use formula. Okay.
Yeah, I did it for the second for the x squared minus x plus 1. Like I did it the way that you just showed us, but
Oh,
for
okay.
I just want to know
Yeah.
if we were able to do it the other way.
Okay.
Okay.
Here I will write Chelsea command here. Chelsea. Okay, exactly.
Oh.
So we can solve faster. We can solve faster like that. I will write down here. We can solve faster. Exactly. That is the thing I will tell you. Okay, x squared plus 9 we can solve faster. We can write x squared is equal to -9 and this it become 9i squared, right? And this become to 3i squared. And after that you get x is 3i or x is -3i. Okay, you can solve like this. Okay. This is very fast. Okay, very good, Chelsea. So for this equation, this is special. You can do like this, but for the second one, we cannot do like this. Okay. Okay, but in the case here, you can solve this to be faster than this methods. Okay. Thank you. We go to the second equations. X squared minus x plus 1 equals 0. Okay, so now we need to calculate the discriminant, right? B is -1, C is 1, and D now is B squared minus 4 times A times C. Minus 4 times 1 times 1. So it's become -3, right? Okay, -3 less than 0. So we have two solutions. So we have the first equation is the first solution is -b plus I times absolute value of d over 2a. Okay. Now we can imply that the absolute value of d is 3. And now we replace b by -1. So the negative of -1 here plus I times square root of 3 over 2, right? Now we need to simplify this. Is it 1? Negative of -1 is 1, right? Plus I times square root of 3 over 2. Okay. And you can write it separately, the real part and the imaginary part. Okay. It should be like this. And about x2, x2 is similarly over 2a. So it should be like this. And you simplify it so you get the result like this. Okay, so now we have totally 4 solutions, 4 complex solutions in this example. Okay, so we need to combine this solution here, and solution here, and solution here. So we have 4 solutions in these equations. So we need to conclude that we have 4 zeros. Okay, we have 4 zeros now. Here is 3i, -3i, 1/2 square root plus I square root 3 over 2, 1/2 minus I square root 3 over 2. Okay, that is 4 zeros we need to find in these equations. Okay, any questions? Okay. Okay, thank you. So so I will go to the next examples, which is similar, so you can practice. Example 4. So now I will let px be given as follow. Okay, the question A here is, okay, so I need to given the factor for you. Given x squared minus 2x plus 4 is a factor of px, A here is factor px completely. Sub B here is phi all 0 of px. Okay, so think about this in a few minutes, and I will show you after that. Okay. Okay, so now I continue to solve the example here because we study online, so I cannot allow you to go to the board to do the example to get bonus point. Okay, so so we will have the in-person class in the next Monday, so that you can go to the board to do the examples. Okay, so now it's difficult to do it because we do it doing online class. Okay, so now we go to the part A of this example. Okay, so to factor here, so we need to divide. Okay, similar to the example 3, we need to divide px pi x squared minus 2x plus 4 to find the quotients, and after that we can factorize. Okay, and here we have to divide it, right? Okay, write the divisor now. Here is in the left, and write the dividend in the right. Okay. So now we have the little term here is x4, and the little term here is x2. And x4 divided by x2 is x2, right? So we put x2 here in this line. Okay. So now we need to multiply x squared by to the divisor, right? Multiply this. So we x squared times to this one. So you will get this be x to the power 4 minus 2 times x cubed plus 4x squared, right? So you get this one is x4 minus 2x cubed plus 4x squared. Okay, now we subtract these polynomials. So we get x4 minus x4 is 0. We don't need to write it out here. -4, we need to -4 minus of -2. So it's the -4 plus 2, right? So it's -2. So it's a -2x cubed here. Okay, and 9x squared minus 4x squared is 5x squared. So put 5 squared here. Negative 10x plus 4. Okay. So now we have new little terms, right? New little term, right? So it's in negative 2x cubed. So now we divide negative x2x cubed to divide by x squared. So we have this negative 2x. And now we move negative 2x to this line. Okay. And after that, we need to multiply negative 2x to the divisor. So we get negative 2x times x squared minus 2x plus 4 here. So it's equal negative 2x cubed plus 4x squared minus ax. Okay. So put it in this line. Okay, so now we need to subtract whole polynomials. So we have this guy is x squared, right? Because 5x squared minus 4x squared is x squared. So negative 10x minus of negative ax. So we need to write here negative 10 minus of negative 8. So it's equal to negative 10 plus 8. It's negative 2. Okay. So it's negative 2x here plus 4. Okay. Okay, so now we divide one more time. So x squared here, divide by x squared is 1. Okay, so put 1 in this line. Okay. And after that, we get the result here is 0. Okay, this is a reminder. And the quotient here is x squared minus 2x plus 1. Okay. So we find the quotient now is x squared minus 2x plus 1. Okay. And after that, you can imply this px can be written as, okay, because we have this is a factor, right? So it's x squared minus 2x plus 4 times 2 the quotient. Okay. We stop here or we can continue to factorize.
You can factor.
We continue.
Yeah, exactly. We can factor this guy. We can factor this guy. Okay. Thank you, Chelsea and Mohammed. So we can do this, right? We can do this. The first one, we cannot do anything, but the second one, we can do this. We can factorize x minus 1 times x minus 1. So it's become to x minus 1 squared. Okay. So that is the way to factor the polynomials. Okay. And that we finish the part A. Okay. Any questions so far? Okay, if you don't have any questions, so I will move on to the part B, find all zeros of px. Go to B now. Okay, so that means we need to solve the equations. Okay, we need to solve the equation bx equals 0. That means that we need to solve x squared plus minus 2x plus 4 times x minus 1 squared equals 0, right? This is the product of two polynomials. So we have x squared minus 2x plus 4 is 0, or x minus 1 squared is 0. Okay. And here we see we can solve this equation first because it's easy, right? It's easier than to solve this equation. So we do focus on this equation first. X minus 1 squared is 0. That means x minus 1 is 0, right? And after that, you get x equal 1. Okay. So that is the first pre-rule 0. Okay. And now we go to the second equation here. X squared minus 2x plus 4 is 0. Okay. So here, I think you can use the quadratic formula to do it. Okay. And a here is 1 B here is -2 and C here 4. So the determinant now is B squared minus 4AC. So now you need to relate them. 4 times 1 times 4. So it's become 4 minus 16. So you get this is the -12. Okay. So it's less than 0. Okay. And after that, you have two solutions. Have two complex solutions. The first one is -b plus I times square root of d of square root of absolute value of d over 2a. Okay. So now replace b by -2, right? Negative of -2 plus I times square root. Okay, we need to calculate absolute value here. So it's a 12 over 2. Right? Okay, so we simplify this. It should become 2 plus I square root of 4 times 3. Okay, similarly to the way to do this. 2 over 2 is 1, right? Square root of 4 is 2, right? Square root of 3 over 2. And you simplify this, it should be like I times square root of 3. Okay, this is the first solution. And similarly, you have I2 is similar. It should be like this. And relate here, I times square root of 12 over 2. So simplify it similarly like the way you simplify this number. So you can get this is 1. Okay, sorry, is it plus, right? Sorry, is it plus? And this is minus. Okay. So we have two solutions here is 1 plus I times square root of 3 and 1 minus I times square root of 3. And we have one more solution we saw at the beginning is 1. So in this case, we have totally three solutions. Okay. So we have 3 zeros. Okay. The first one is 1. The second one is 1 plus I 3 and 1 minus I square root 3. Okay, that is 3 0 we need to find for this polynomials. Okay. Any questions so far? Okay. So I think that is enough for this section. So we finished section 3.5. And you can practice more by doing some homeworks on Canvas. So I will stop sharing my screen. Okay, so I will share my screen now. You can go to my Canvas. You go to your Canvas and do the homework. So the homework 6. So it will be due on this Sunday. Okay, not Tuesday. This Sunday, because the homework now you can do all the homework now. So the homework 6, all of them are taken from the final exams. Okay, and you can apply the methods I tell you this on Monday and on Wednesday. You can do all of them. Okay, and the deadline for the Sunday is Sunday this week. Okay. Any questions?
Yeah, I have a question.
Okay, questions.
When our next test?
Sorry.
Our next test.
Next test. Okay, next test is after spring break. No worry at all.
I believe it's March 22. So
The test will be on after the spring break. So we will not have any test before the spring break. So no worries at all. If we have the test, I will let you know on Canvas before 2 weeks. Okay. Any question more about this?
Yeah, Professor, do you still have that screen with the notes? What were our zeros for that last one?
Sorry.
Can you share your screen again with the notes?
Okay, so I will share my screen again. Okay, stop sharing here. I need to share now. Okay, can you see my screen now? Okay, question? What question you have? Cole?
Oh, I just wanted to see what our zeros were
Here?
for the last one we were working on.
The last one here, right?
Because we're supposed to find all zeros.
By all zero, yeah. By all zero.
So is one of our zeros, correct?
Yeah, one is a
From our
It's a-
quotient?
yeah, one is zero of this polynomial.
Okay, so we have 3 zeros after that.
Yeah, 3 0. Yeah, this is the conclusion. You have 3 0 now.
Okay, just making sure.
Okay, that is 3 0. We need to find.
Thank you.
Okay, any question, guys? Okay, so we will not have the test, the second test, before the spring break. Keep it in mind. But you need to prepare 3 blue book for the test 3, test 2, test 3, and final exam. In this time, I will collect three blue books. Okay, I will let I will write the announcement in more detail on Canvas. Okay, if you don't have any question more, we will stop today. That's enough for today. Okay, have a good weekend.
Good weekend, Professor.
Thank you.
Okay.
Again.
Okay, bye bye.